sorry I can't be here again today. So I thought since I can't be here that I would video our lesson for today and what we were going to do. So today's topic is cube roots, and you should hopefully have gotten your calculator. If you don't have the calculators out, if this video could please be paused, one person from each table with the calculator numbers, go over, get the calculators, and come back. Okay, everybody got calculators? Great. Let's move on. So we've talked about square roots, and with square roots, we looked at a flat two-dimensional figure, and we talked about what is the root of this. So what is the length of one side? And that was a square root. Today we're going to look at cube roots. Cube roots are going to be three-dimensional. So now we are looking at all three dimensions, and in a cube all the sides are the same. So what is the cube root? So in this case I have a 2 by 2 by 2 cube. How many smaller cubes make up this larger cube? 1, 2, 3, 4, 5, 6, 7, 8. So you should see that there are 8 cubes, smaller cubes, that make up this larger cube. So what is the length of one side on this cube? Well, you should notice that it is 2 cubes long on a side. So the cube root of 8 is going to be 2, because 2 times 2 times 2 gives us 8. Let's take a look at another cube. So that was a 2 by 2 cube. Here is a 3 by 3 cube. So I've made each layer a different color. Each layer has 9 blocks on it, and there are 3 layers. So we have 3 by 3, 3 times over. So how many blocks is that going to be? Well, that's going to be 27 blocks. So then we can ask ourselves, what is the cube root of 27? The cube root of 27 is going to be 3. 3 by 3 by a height of 3. So the cube root of 27 is 3. Let's look at another one. Here's a 4 by 4 by 4. 4, 4, 4 this way. So each level on this one has 16, 4 by 4. And then we have to say 16, 16, 16, 16, 16. So how many total cubes are in this big cube? Well, there are 64 cubes here. So what is the cube root of 64? Well, it's going to be 4. 4 times 4 times 4 is going to give me 64. So the cube root of 64 is 4. So let's take a look at these problems here. With your calculator, please go through and fill in this top portion. So fill in this top portion, use your calculators, and we're going to go ahead and put 3 minutes on the timer. You have 3 minutes to complete this. Okay, timer's right there. Your time has begun. All right, so you should be done or close to it. And here's what you should have gotten. So you should have written out the base number 3 times in each of these scenarios and then multiplied, and here's what you should have gotten. You could have also in your calculator done, just put this in 5 to the power of 3, 7 to the power of 3. Any of those would have been fine. So here's what you should have gotten. I'll give you about 15 seconds to make sure that you have this on your paper. All right, your 15 seconds are up. Let's take a look at the bottom of your page. So up here, these were perfect cubes, just like we have perfect squares. Now down here, we have a perfect cube, 2 perfect cubes, 27 and 64, and in between those is 30. So volume of a cube is found by multiplying the length, width, and height. So V equals LWH. In the case of a cube, we can actually write the formula as V equals S cubed, S being the side length. So S equals side length. So we can take whatever the side length is of our cube and we can cube it. All right, so let's take a look over here. This one's 27, so it is a 3 by 3 by 3. This one is a 4 by 4 by 4, which gives us 64 cubes. And we looked at both of those. So here's our 3 by 3 by 3. And this was our 4 by 4 by 4. But this problem is asking us to find the approximation of a cube that does not have perfect whole number side lengths. So now we're looking at 30 cubes, and what would that side length be? So use your calculator, make some, well first, it's clearly going to be between 3 and 4, right? So it's going to be 3 point something. So go ahead, pause the video right here, and have a quick discussion about what you believe those side lengths to be and how you are going to determine them. So please talk with your table and take about 2-3 minutes, see how close as a table you can get. And then I would like you to please share out as a class what each table got. What did you use for your side length? So go ahead and pause this video right now. All right, welcome back. So you should have hopefully had a pretty productive conversation, and you should have gotten somewhere in the 3.1 range. All right, 3.11 gives you 30.08. Maybe you did 3.10 something. All right, so you can get pretty close, 3.1 something. All right, should have gotten you close to that. And maybe you have a more exact answer. And hopefully you had a great discussion about that. All right, so let's turn our paper over to the back. And go ahead right now and complete this section. What is going to be the approximate cube root of 12? Again, 12 is not one of those nice, perfect squares that we had. So what two is it between, and can we make some approximations? All right, so take about 2 minutes right now to go ahead and fill in this section. 2 minutes. Go. All right, welcome back. Let's take a look at what you got. So between what two perfect cubes is 12? Well, it might be helpful if we were to write out what our perfect cubes are. Well, actually, I guess we do have that on the other side. So we have our perfect cubes here from 1 to 12. So 12 is going to be between 2 and 3. 2 and 3. So if we turn that back over, we see that it's between 2 and 3, which was 8 and 27. That's what we want to say. So those side lengths are going to be 2 and 3. Which one is 12 closer to? Is it closer to 8 or closer to 27? You should have noted it's closer to 8. So what do you think would be a good guess for the side of the volume of a cube with a cube with a volume of 12? All right, so what would be a good guess? Maybe you're thinking 2.5, 2.3. Everybody should have something a little different. So what is the closest measurement for the volume for the cube with the volume of 12? So the closest that we can get with a calculator, and you should have probably done some experimenting with it, you probably got about 2.3. Should have gotten you pretty close. So I would say about 2.3 with your calculator, and then you would have whatever your guess was there. All right, so let's take a look at this table below, and let's see what we have here. So 5, square root of 5. So our numbers we're going to have to look at are 5, 50, 80, and 200. So let's flip our paper over, take a look at those. So 5 is between, let's see, 1 and 2. It looks like 1 and 8. 50 is going to be between 3 and 4. Let's see, there was a 200, which is going to be between 5 and 6. And what was the last one? Oh, that was 200. 80. 80 was one of them. So 80 looks to be between 4 and 5. Okay, so let's go back over and see if we remember what those were. All right, so the perfect cubes here that they are between. All right, so 5 is going to be between 1 and 8. So that gives us side lengths of 1 and 2. Which is it closer to? Well, it's pretty in the middle. I'm going to say it's probably closer to 8. All right, and we're going to go back and calculate those side lengths. All right, so 50, what two perfect cubes is 50 between? And it's going to be between 27 and 64. And that's going to be between 3 and 4. Which one is 50 closer to? Well, it's closer to the 4. Okay? Or excuse me, the 64. Let's see. Next we have 80. And 80 is going to be between 64 and 125. So that is between 4 and 5. And 80 is going to be closer to the 64. 200 is going to be between 125 and 216. So that is going to be between 5 and 6. 5 and 6. And 200 is going to be closer to the 216. So we know that since we can see what it's going to be closer to, we know that it's not going to get exactly to this second number, but it's going to be, if it's higher, if we have the higher number, as in the first two, it's going to be close to that. So 2 point something, maybe 678, possible, or excuse me, 1.678, 3 point, maybe 678, something like that to get close to 64. Now on these other ones where it's, this one is closer to the lower number. So this might be 4 point 1, 2, something like that. And this one's closer to the higher number, so maybe 5.67, something to that effect. Okay? So now if we want to actually go through and calculate this, there's two different ways we can put this into our calculator. So I'm going to go ahead and show you both of them to try and get an exact answer, as close to an exact answer as we can. All right, so the two different ways. So we have our calculator here. So one way is to raise it to the power of 1/3. So if I'm trying to get 5, I can raise it to the power of 1/3, and that's going to actually give me the cube root. It gives me a cube root of about 1.71. My other option is to actually use the cube root function. There is a cube root function, and for that, I hit the second button, and then I go down here, to the math button. Wait, I said that wrong. Ignore that. I hit the math button, sorry. I'm going to go down to number 4, that's the cube root, and then I type in my number. So I wanted to find the cube root of 5. As you can see, I get the same thing. So either one of those is acceptable. I'm going to say that it's about 1.71. So go ahead and take a couple minutes to please find the cube root of these numbers and the cube root of these numbers down here. I'm going to put 3 minutes on the timer. And if that's not enough time, feel free to pause the video if you need more time, if the class needs more time. But for now, we'll go ahead and put 3 minutes. Ready, go. All right, so how did you do? Let's take a look. So here is, there we go. There's what you should have gotten. Please make sure that you are attending to precision and we're very, very precise on your rounding. I chose to round to 2 decimal places. So here is what I got for each of those. And then down here, these were perfect cubes. Notice that they have no decimal in them. So you should have gotten answers for those. All right, well, that concludes our little lesson on cube roots. I should be back tomorrow and we will do some practice real world applications with cube roots. The rest of today, though, you will be doing some practice with cube roots. Hope you guys have a great day.